All right. Good morning. It's been a few days since I had this stream now. I guess it's because I don't know, just want to do other stuff. And yeah, I'm constantly trying to figure out what this stream is, and I think it's better to do it instead of like committing to like a long-term thing. Just do smaller ones when I actually have something to talk about. That said, it has been super fun to explore the like the visual state management stuff that we worked on, refactoring code sandbox stuff. But it got to the point where, okay, I feel confident that this is something that can actually be used. Um, and we might use it. We have to make that decision soon because we're building some new stuff at Code Sandbox. So that's going to be exciting to see what we end up with. But I also wanted to like flip it around and think about how could we use only React, like still have these benefits of like testability, separating our features from the UI, and yeah, and basically have some predictability, and especially dealing with like I talked a lot about disposing stuff, so that when you move, like when you interact with the app and you move between states, that you don't have like previous asynchronous logic suddenly overriding the new state, where the example was typically like in the dashboard, you open a workspace, you change the workspace while the previous one is loading, and suddenly you are loading the old workspace on the new workspace. It's just fundamentally how the application is architected, and it's like very common mistake, because we don't really have good abstractions for dealing with that kind of stuff. We kind of just trust that things move fast enough to not get into those situations. Anyways, so what I've been thinking about is so some people like to co-locate their UI with the logic, and that works just fine to some extent. It's when you do like very complicated stuff, like at Code Sandbox, we are moving into this, or we're moving away from this monolith of having a single client to rather having multiple applications. So you can think about the different pages of Code Sandbox. Each page is becoming so complex now that they are in themselves their own applications. And we want to develop them in isolation, but we don't want to, it's still like one app when you actually visit Code Sandbox, but we treat them as individual applications. And to do that, we have to, it's ideal to separate the actual application logic from the UI. So it's easier for us to do testing, and that we can use the same application logic with different UIs, right? So that's what we're going to explore here, only using React. So let's have like this features folder, and let's do something like auth, and we'll do it as a folder because sometimes you do have like related, well, one thing is you want to test it, so you want to have the test file there as well, but you might have like utility functions or other stuff related to as React from React. So what we're going to do is to create like a React abstraction that deals with the stuff I talked about, like some form of dependency injection. One thing with React is really important to think about is performance. It's super tricky. So we have to talk about that as well. And then like how do we expose and use the functionality and compose the features together? So like one feature might need information from another feature, for example, where auth is a very typical feature where you want, which you want to use in other features as well. Anyways, let's do like a basic thing. So when you want to expose an isolated feature to a React application, you use a provider. So you create like a context, and then you export like a hook. In this case, it will be like use auth, and that is basically just use context, and that uses this context. And then we need to export like a provider. So auth provider. And this would return the context provider with some value. And then we need the children in here. And context provider. Okay. And so now so this is the cool thing about context providers, is that they are kind of like dependency injection. So now as long as I'm exposing the auth provider at some level of my application, I'm able to use auth wherever I want. And then I can start doing stuff here. Now, the tricky thing about these providers is that you don't want them to re-render too often. Because what happens here is that whatever uses this hook, whenever this value changes, it will cause any component using this to also like reconcile again, which is pretty bad. But what you can do is, and it also depends, like some providers are at the very top of your application. They won't cause a new reconciliation, because you don't really reconcile at the top of your application. You're just providing stuff, right? But as we start composing these features together, and some of these features are actually nested in the components. So for example, we would have like a sandbox feature, and that would be nested down at the level of the editor. And that will probably depend on the auth provider, or like use the use auth hook. And if something happens to the user, or you're signed out or something, that would like affect all the components that depends on auth. But there are features that don't depend on auth, right? Which should then not cause a reconcile. So it's kind of thinking about this. This is a huge complexity in React, is to think about how the more like when you think about use state internally in a component, it's quite straightforward to think about when does it reconcile. It's when you call set state, right? But when you abstract to these separate concepts, you have context providers, it becomes super, super tricky to like build that mental image of how the reconciliation will actually work in the large scheme of things. Anyway, so if we have some or like auth reducer, yeah, use reducer, and we have some reducer there, and then some initial state. I'm not sure what it is complaining about. Is it because I don't say state action? Anyways, I have to type this anyways. But the point is, we want to pass this reducer down. And what's good about this approach is that if there's a parent here causing this auth provider to reconcile, this value won't change. It will be the same thing, which means that there won't be a cascading thing. So as long as we make sure that we just pass down this thing, we've considered some optimizations or preventing some unnecessary reconciliation. And the problem is that typically you would have logic here, like you would expose some actions or something that you could, or callbacks that you could call to change the internals of this reducer and run logic and stuff. And that's super tricky because you can't really do that in an effective way. Because even if you were to like do React use callback, which would ensure the callback itself doesn't change, you would still like need to hook that callback onto like an object. And now this object changes every time this auth provider reconciles, which means that it does indeed render. So we really want to do this. And the reason I'm even thinking about this is because of this React states thing that I worked on. Which allows us to actually only expose this thing and still have logic. So let me show you how that works, in case you haven't seen it. So what we're going to do here now, let's write out like an auth auth thing. And maybe we could even try to refactor what I did in the other solution to this concept to see if it holds up. So let's just do this. It might be an error if we're unauthenticated. When we're authenticated, we have like a token, something like that. And then we'll have type action of action equals type would be sign in or sign in success or sign in error. Here we would have an error. Here we will get a token. Okay, cool. So we have our reducer here. And let's just do it. Let's export this. Let's export this. And what we're also going to do, we're going to move this reducer to actually be the official reducer for this feature. And we give it a typing. Oh, auth state auth action. And we're going to transition this state with the action and then unauthenticated, authenticating, and then authenticated. And now we need the state here, unauthenticated. Yes, unauthenticated. Okay, cool. So this is like the basic of a feature. A feature is a reducer where the state and the dispatcher is exposed through the context on the value here. And this is optimized. As I said, there's no risk that some parent triggered reconciliation will suddenly cascade to this insanely big reconciliation of the whole app. Because you have to explicitly change this reducer for this value to actually change. So now the question is like, how do we actually trigger logic from this? And with the React states concept, we actually do a use effect for that. So what we can do, we can now destructure state and dispatch auth reducer. So whenever the state changes, we'll do the exec thingy, which is when we're authenticating, we are going to like run some logic and dispatch. So what happens now is that whenever we dispatch the action of sign in, we can write this out, sign in, then we're going to move into the authenticating state. And then we have the sign in success, which gives us the token authenticated, where we need the token. TypeScript is helping us here. That's awesome. And we have the error, an error. And this will move us into unauthenticated with an error. Okay. So this is like the basics of it. Now the question is, how would we, well, first of all, we're going to do one thing, and that is all the stuff we're doing here. This is going to be exactly the same for all the features. We're going to have a hook, we're going to have a reducer, and we're going to have a provider. So what we can do is that we can create an abstraction over this, so that the only thing we really have to do is that we only define this stuff, and then we return what the context provider should have as its value. Okay. Yes. So let's just do that quickly first. So let's create something called like create feature. Export cons create feature, and I want this to take a generic, and I'll explain why. So this is going to be like the actual create feature, which is going to return, well, we need, so P extends, this is going to be like a feature might, like the provider of a feature might require you to actually pass some additional values. Like not only, like by default, the provider doesn't take any props because it only exposes its internal value. But you might want to provide some outside tools. So this is what this P represents. I'm going to show you how it works. And then we actually have the value. Let's call it V. So we create the feature here, and it will receive the outside props, and then it will return this value, and that will let's see, this is going to return, oh sorry, maybe we don't have to type this, or do we have to do that? Yeah, maybe we do. So this is going to return, wait a minute, like that. There we go. Or wait a minute, where are we now? This should be, oh, equals. Oh, sorry. I'm messing around here. I thought I was typing here, but I'm not. I'm typing here. Anyway, so this is going to return an object where we have the provider. We're going to have use feature, and we're also going to expose the reducer itself. Well, yeah, that's a tricky thing, I guess. Oh, anyways, let me just do what I intended to do. Anyway, we're getting a thing here called create feature. So we need to create a context for this. Create context, import as React from React. So we're going to create the context, and this is I think actually we can just call create feature. No, we can't do that. So null as a known as V, okay? Because this is the V is going to be like the context value. Maybe we can call it C, like it's context, like that. And what we're going to do now is we are going to have use feature, which is going to be like a hook where we do use context. Sorry, I'm messing around a little bit here, but you'll get it. And then we're going to have provider, which is going to take props, which is basically the children. It's going to take children. This is the actual like provider component. It's going to take that, and it's also going to take whatever we say P is here. I think maybe this should be never or void or something. Yeah, let's try that. Let's see how that acts. And this is of course going to be, oh, this needs to be TSX. Context.provider. The value here is going to be this create feature. And then we're going to pass in the props. And then we actually get props children here. Like, this might not make any sense right now, but I promise you it's going to make sense. Okay, so what happens here? First, let's consume it, and then you'll see what I mean. So let's import create feature from create feature. Now we don't need this. We are rather going to const feature equals create feature, and we are going to we can still have our reducer there, but we're going to all this logic here, we're going to put that into oops, there we go, there, and we're going to return our auth reducer. And then we're going to expose use auth as use feature, and then export const auth provider, as the feature provider. So create feature is this generic thing for creating features, and then we're being explicit about what this feature actually is. And the point is that now we've created a nice abstraction over building a feature, where a feature is basically just a value that is being exposed in the context of React. And with our React states concept, we're able to make this safe, because whenever this reconciles, if nothing has changed, like if it's reconciled by a parent, this will always be the same value, and it won't cause its cascading thing. We can use the dispatch to change the state of the reducer, and then the feature itself reacts to these state changes and drives further dispatches and state changes. Okay, cool. Now the thing is, we want to run some logic here, and the thing is, like, how typically you just import something. So you would like import Axios here, for example. But I don't think that's a good idea for the complexity of an application like Code Sandbox. If we were to do something like this, we need to expose those tools from the outside. Now the question is, should you have like one feature per tool? But that doesn't really make sense to me. So what I would do is I would create a feature called, for example, imports. And imports is basically just taking props from the outside. I'll show you what I mean. And these props are different tools that other features can use. So an example of this would be, we're creating a feature, and now we're going to say that this actually requires some props from the outside. So we're going to say props here, and we need, for example, HTTP. And we're going to just write the interface for this. And we want this to have like a get thing, where the URL is a string, and it returns a promise of some value, right? So what we can do here, we can basically just return the props. That's the thing we want to expose. Well, maybe not the props. Maybe we should return. Why is it complaining, by the way? Yeah, we'll figure that out. Anyways, so maybe we should return. I'm not sure why this is complaining. Oh, type void, sorry. It's me putting stupid stuff here. Extends, it needs to extend an object. Yeah, let's just try this for now. So basically what we want to do here is we want to create a provider where you can give it outside tools. Like you could give it Axios or whatever. It's stuff you want to mock, really. And then we do the same thing. We say use imports is feature use feature. And then we have imports provider. Okay, so how would we actually use this? Let's use it in a feature first. So here we have our actual feature. And what we want to do is actually use the HTTP. So we can just do that. Use imports. Like that. And now I actually have HTTP. The only restriction of like dependency injection using context in React is that it can't be circular, which other tools can. But that it's typically a good thing. But it is it forces you sometimes to restructure your app in maybe on a natural way, because some things are just circular. You can typically get past that, but yeah. Anyway, so that means that our imports provider has to be a parent of our auth provider, right? So what we can do here is now we can say HTTP get user, then we get the user here, or like a response or something. Like, it doesn't matter. Let's say we try to get the token. And we get the token, we can just say we'll get a string back here. And what we're going to do, we're going to dispatch type sign in success, and we got the token. And then when there's an error, and the reason we're not using async await there is because these functions are considered React effects, which means you can return a function from them, which are disposers. So this will be an error.message. Cool. Not sure why this is complaining. Oh yeah. I wonder why it complains about dispatch. Because that's actually not necessary. Maybe it doesn't understand that. Maybe I actually have to use the dispatch here. Wow, that's really silly. Can I do like this? No. No, I want this to be the thing. Like, I don't want to create a new array when I return it. So I kind of have to do it this way. That's silly. That's super silly that the linter doesn't. Anyways, okay, so now this is running like internally. We're actually using something from the outside, which means that when we write our application, we can say imports provider, and we have our auth provider, and then like we have some app running here. Okay, and the imports provider now requires us to pass in HTTP, but we shouldn't require that. And the reason is that if we're going to write a test for this, it means that we have to pass in. So if we have like, maybe we have like 20 different tools coming from the outside, we would have to like mock all of them to make TypeScript happy. So what I would do, I would rather make them optional. So we don't actually have to pass it in. But that's what you would do. You would say like, and if it was a matching interface, you could like pass in Axios here, for example. Or we could do, yeah, maybe we can add Axios. So you would create a contract through an interface. Axios from Axios. And then, oh, it does fit. Oh, that's nice. It actually fits the interface. So yeah, that proves my point even better. So you have defined like, what am I going to use HTTP for? What do I expect in terms of typing? And then you can provide some tool, and that gives like the two flexibilities. You can change out Axios anytime you want. And it gives the flexibility of mocking this out when you're running tests. So maybe we can like write a test for auth now to see like how that would look like. So index test, I guess TSX, and describe auth, something like that. I'm not sure if I'm actually able to write a test here because I'm testing using React. Should do something. So let's just kind of write it out in a silly way. So the way you would do this is that you would actually write your tests as components. And we would do something like, so if we wanted to test like the actual feature, like we don't care about the UI here, but we would create a component for the test to actually trigger the feature. So we would do something like, test, and this would, let's see, state dispatch use auth. Ah, come on. Right, so this is our test, and then we can do our validation in here, and we can like trigger the dispatch and all that good stuff. And then we would actually write out or maybe we can like what should we call it? Trigger I don't know. My point is that the test would be like imports provider. It would be now the auth provider. That's what we're going to test. And then we would like render our trigger. Oh, return no. Cool. So my point here is that, what is my point? My point is that now, well, my point is pretty clear. It's that you can actually, yeah, and here we would have like an HTTP mock. So you would do get, return, promise, resolve, for example. What are you not happy about? Oh yeah. Resolve, hey. Oh, come on. Oh, maybe I have to do this thing. No, what the hell? Why is it? T could be with an which could be unrelated to string. Yes. So okay, anyways. So as you can see here, I'm now mocking HTTP effectively. I have my auth provider with all its logic, but it's not talking to the outside world at all, but it contains the reducer and the effects, which means that I should be able to like go to this thing, and I can like create like a silly UI for this. I don't have React testing library. How do you do that? I actually never used this. Blah blah blah. Example. Blah blah blah. Blah 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 blah. What is all this stuff? REST. Yeah, so this is what I don't like. I don't like how we try to mock our imports. I think doing some sort of dependency injection is way better because there aren't any side effects there. And you can use it for any tool. Here you have to have an explicit mocking tool for REST, which is, for me, is just crazy. But anyways, so how does this work? It renders, fire event, click screen. What screen? Okay, I guess it just magically understands this. Does it run one? I guess it runs one test at a time then. That's interesting. Anyways, so you would like write some kind of UI here, which will like trigger the dispatch, and maybe you would kind of have the, let's see, auth. Let's call it auth. So maybe you would have auth state here, and then you could like check if you moved into the correct state and stuff like that. Yeah, I haven't really explored this, but my point is that you are able to test a complete feature in isolation, And since you are able to mock out any dependencies, that's a good thing. And like it's very much isolated. And you can imagine having a feature that that's more complicated. That's like it needs the auth provider and it's like another provider, and then you start testing it. So you can test really like it's more of integration test, but you don't like need a full app, which is good. Like it can be quite heavy to fire up the app to do full integration tests, but here you kind of get this middle ground of it looks like a unit test, but it's actually an integration test. It writes like a unit test and runs like an integration test, kind of. Anyways, so this would of course not work just like this, but it's something I would have to explore. Okay, why are you mad? Object, oh, I didn't think about that. Yeah, so if we make them optional, they're also optional here, of course. I could of course fix that. Maybe we could do like props as I think there's like a way to TypeScript convert optional keys to required. Oh, do you just say required? That's right. Required. Let's export props. Maybe that works. Yeah, it does. That's cool. So the point is that we want them to be optional because you don't necessarily have to implement them. And if you forget one of them, like in the running application, you would instantly get a runtime error. So that's perfectly okay. It will be extremely explicit. Like it would say HTTP is undefined, and you would instantly know that, oh shit, I didn't pass that import to my application. Anyways, so one thing I thought about this, it would also be ideal to be able to set the initial state of the reducer as part of this. So in the provider, you would have this initial state prop. And that would actually be passed into, well, it could do that by itself, I guess. So create feature props p. I'm not sure. Anyways, doesn't matter. How much time is the time? Cool. So the thing is, the way I'm thinking about this is that, so you're going to implement like a new feature. So you're thinking about that. It might be something like, yeah, for example, a sandbox. So you would implement a sandbox as a feature. And you would do this kind of thing. You would say, like you would start typing out the states. I'm not sure if a sandbox really has different states. It's all kind of updating it within the same state. But it could be, well, it could be frozen. Yeah, like read only. It depends, like how, this is the tricky thing about using explicit states is that you really have to think, like, what does this actually mean? How do I want this to work? And that's a good thing, but it hurts. And I think that's why people are opposing it, because it feels so much simpler to just, okay, I just have this sandbox and I don't really care about its overall state. I just have a bunch of state values and I want to change them from time to time. But basically what we mean is that what are the states of the sandbox in this case, where we want to prevent certain logic to run. So for example, if the sandbox is frozen, we don't want you to be able to save the code, for example. So we could do that. What should we call that? Like, what's not frozen? Melted? That was a bad joke. Really, really bad. Yeah, what would we call that? What would we call that? Oh, frozen. Let's write frozen first. It might be frozen. And the data would still be like sandbox data. So let's export interface sandbox. Like, it would have an ID, it would have other stuff, but it would still have the data there. So what would the initial thing be? Would it initially be what's the opposite of frozen? Well, maybe this is not the state I want. I'm not sure if I really like, is there any, should a sandbox have like any guarding logic? Well, it's definitely related to if you are the owner or not. Like, you have permissions. You have owner, write, and read. And that's definitely needs to be guarded. Anyways, let's do that. Owned. I still have the actual sandbox, but it's like a different state. This is not it either. How would this work? I think I'm doing the opposite way. I think we should just have like ready. Let's just do this, and then it's better to explore that later. So the kinds of actions you would define here is all the actions for actually changing the state of the sandbox. So that will be quite a bit of actions. So for example, change description. That will need to be a specific action. And then we will create a feature. Export. And what's in, so the interesting thing about this one is that feature, use sandbox. Yeah, the interesting thing about this one is sandbox provider. So the reason I wanted to show this is because this is a different kind of provider. This is something that will be nested in the application itself. So you would actually want to receive like a sandbox. You would actually want to receive a sandbox here, right? So you can imagine like you have an editor component, and the editor component is responsible for actually fetching sandbox data from the server, and then it renders out a sandbox provider and gives it that data. Maybe we can even call it data. And the point is that we would actually sandbox reducer, use reducer, and then we can define that here. State action. Oh, this would be like sandbox state, action state, and we would do the transition stuff. State action. Cool. Okay, use reducer, and the initial state would be ready, and we would give it the data. We can do structure this. Now the nice thing about this, and this is the interesting thing about the React approach, is that this sandbox provider would have a key, and that key would be the ID of the sandbox, which means that if we were to change out the sandbox, like it would flip to a new sandbox, it would actually kind of just remove that feature and load a new one, which is exactly what we want. And this works in the other concept as well, because it has this explicit concept of disposing. But I think React would be smarter about it. So in the other solution, it will kind of rip out the whole sandbox and then kind of render everything again, reconcile everything. But here, I think it would be smarter about it. I think, maybe. Because you might have, so imagine like you have a sandbox and you have like the whole sandbox experience. A lot of those pieces of the UI don't necessarily depend explicitly on the sandbox. So for example, adding dependencies to that sandbox, that will be a feature, but it doesn't depend on the sandbox feature itself. It just lives within it, which means that whenever we would change the sandbox, it would flip the provider at the top, which means that anything using the use sandbox hook would also need to reconcile again, which is correct because we changed the internal state of it. But all the components that doesn't use that hook, they don't need to reconcile again. But maybe this is true as well for the other solution, because there we would, yeah, I guess this is true for the other solution as well. But yeah, this is the tricky thing. This is like how I'm trying to, it's so difficult to find like a good architecture at the scale we're doing it at Code Sandbox, because there's so many factors. Like the other solution is appealing in the sense that we're dogfooding our vision of visual tooling. It's like object oriented, uses classes, which arguably everyone understands, while functional code is really tricky for, like, it's interesting, this mental model, like what fits better for your brain, functional code or object oriented code. Yeah, but arguably people kind of, at least that's my experience, if you understand functional code, it's there's a higher probability that you also understand object-oriented code, even though you don't prefer it. Well, if you have a hard time understanding, or if you are like object-oriented mind, you have a very hard time understanding functional code. And you just see how we write this code. Like it's super composable, but it's more mind-bending. You have to think a lot more about this stuff. Maybe I have an object-oriented mind. Anyways, return sandbox reducer. So that's like you have the factor of like the dog fooding factor. You have, okay, a lot of people are going to work on this. Maybe it's better to just use the primitives of React because then everybody kind of understands that, but we still need to create these abstractions. So we are building an API here anyways. So it's not like just using React. We need to create some abstraction over it to be able to separate our logic and make it testable and all that stuff. And make it performant, not the least. Yeah, it's a really difficult decision. But the good thing is that we're scoping down like the first thing we're doing, so it doesn't really matter what we choose. We can change it after we've done that. It's going to cost to change it, but I guess it's worth the try. But yeah, anyways, so what would happen here is we just put the data into the reducer, and now the only way this can change is that you dispatch. In this case, we dispatch change description. We would have the data here, and we would just keep the state. We're still in the ready state. The data would be data and then description. Oh, sorry. This is where the description is. This is where the data is. So we would do it like that. So it means you dispatch whatever changes you want to make. But this would be like an insanely complex thing. Like the sandbox data is a lot of data, and also it has modules and directories, and it needs logic for changing those and saving them. There might be errors saving them. Like it's a lot of complexity. This would be like a huge feature. And you don't really have, so that's what I don't like about this. So in our other state management solution, you would isolate the sandbox to actual sandbox stuff, and then you could create like a sandbox module feature, which takes care of a single file. Like a module is a file in Code Sandbox. So what you would do is you would get the data for the sandbox, and then you would go through it. You would attach it to a class, which would allow you to just change it instantly. You wouldn't have to you don't have to put everything behind like a dispatch. And it would also allow us to like go through the array of modules and actually create instances of sandbox modules, which holds its logic for dealing with modules. Yeah, that's the thing. And we're not able to do that here. When you work with these reducers and you have very complex state, it becomes quite unwieldy, because the reducer itself kind of, you can't like have a well, I guess you could have like a sandbox, like you can't instantiate reducers dynamically. Like I guess you can, like, I'm not saying reducer, I mean like these features, which are like providers, they have their own React context. Like you could have a provider that's called like sandbox modules. That would be possible. Yeah, that's interesting. So you wouldn't put all this logic in here. So the sandbox would actually just be the ID and the overall state, and then you would actually have your own feature for the modules and the directories. You could even call it like sandbox file system. That would be the feature. And that's where you actually pass in the modules and the directories, and then it will hold the logic for dealing with those. That is certainly interesting. But just, yeah. Yeah, maybe we should just, okay, let's finish off with that. Because I need to like demo this stuff. What do we call it? Sandbox file system. So that's a feature, create file index.tsx. And the thing is that this would actually use the sandbox. So let's just copy this. We just need yeah, and that's also something I want to, let's see. Sandbox file system state action. Oh, action state. That's not right. Sandbox action. Sandbox file system action. Cool. So yeah. Yeah, because that's the thing. Like, you might not need to have these explicit states. So in this case, there's nothing really. There's no guarding needed for this specific state, right? It's you just have the properties of the sandbox, like the description, the privacy, the tags, stuff like that, and there's nothing really preventing you from doing anything in any state. So here you could just basically just have a plain reducer. Yeah, you kind of have to discover these implicit states. Anyways, so the point here is that sandbox file system action data, here you would have like modules. Let's just do modules for now. And then you have a module, and that module has an ID. It even has a short ID. It has some code. It might be is binary. That's something we have there. Anyways, something like that. And then you would have like add module, for example. Of course, it has a name or a title. I think it's called title. Cool. And then yeah, we're still doing this ready thing, and then we would have, and the point is that these modules, they would also need to have a state now. So it would be for example synced or something. So we would add module. So it could be synced, it could be what's it called? It could be dirty, it could be syncing, and it could also have an error. Okay, let's just have those. So the point is that when we add a module here, it has a title, we have the modules, and what we would do is we would return the same state. modules. And then we would add a new module, which would then need like an ID, whatever, 123, short ID, whatever, 123, title, code is binary false. And let's see, state would be like dirty. What am I missing here now? Don't I have everything now? What are you complaining about? Oh, short ID. There we go. Yes, I'm just calling it dirty for now, because the thing that would happen now is that we would say modules modules, right? And then we would say React use effect. But yeah, I'm constantly getting this feeling that this is going to be like way too complex. It's just, let's see. Oh, this is file system. One thing is that it's in risk of not being performant because there's tons of reconciliation going on. We don't have the insight, we don't have the visual tools to actually understand what's going on inside the application. And the thing is, like, the reason I'm talking about this at all is because doing plain logic doesn't work for Code Sandbox. We need a lot of predictability in our code, and just doing if we were to use Redux, we would just have thunks and we just import stuff and just run it, and we wouldn't care about what state we're in. And there's so much asynchronous code running, and it would just override state, and like it just doesn't work. We need something more sophisticated than that. And even the Overmind that we're using now doesn't have explicit concepts for dealing with like guarding actions. Like actions are like things in Redux. You can just call them whenever you want, and they will just change the state. It doesn't matter, which is why Overmind does have state machines and also state charts. But they don't have the concept of disposing. So even though it helps you guard your state and logic, it won't do like disposing. So we need something more than that with the complexity we're dealing with. And this is dealing with that complexity. This code is actually dealing with that complexity. The problem is that the code, the concept itself, I don't know, it just feels too complex. The other visual concept seems a lot more approachable. It seems to me. Ready. So what we would do here is we will have like one effect that would like look for dirty modules. I guess you can only have one at a time. So it would do like modules find where the state equals dirty. And then if you have a dirty module, it would go ahead and it would actually save. So again, here we would probably need like HTTP from, or use imports. Go ahead and and save it. And what it would need to do, it would need to like dispatch something like saving module, something like that, and that would put it into like a syncing state, and then it might move from the syncing state to either synced or error, or it might actually move to dirty again, because you might still be changing the module while it's being saved, which means that when you're syncing and you're dispatching a successful sync, it checks, is it dirty again, or is it still, if it's syncing, it means we move to synced. If it's become dirty again, it means well, then it basically means it should just keep it as dirty, because then it's already being saved again. Well, sorry, that's not right. What I meant to say is syncing dirty. We need that state as well. So if you're saving the module, it will move into syncing. If you change it while it's syncing, it will be syncing dirty, and nothing would happen. And then when the initial syncing is successful and it's just syncing, it will be synced. But if it's syncing dirty, it will move back to dirty, which again would trigger another save. That's the thing. But yeah, and this is the stuff we really want to deal with. We want to make sure that all these patches or whatever we do triggers in order. We want to make sure that like the initial syncing here might fail, so we don't want to like run another one. And if you were to move to a new sandbox while it's like syncing a module, we don't want the new state to be overridden with this stuff. And that's also what we're dealing with here, because the provider, it will be like a new sandbox provider with new state and everything. And what's been happening inside here won't happen again, because we created a new provider for it. Yes, that's it. Anyways, I have no idea if this was useful for anyone, but it's just, yeah, I needed to, this was just for reflection. It was not like this is awesome. It's just pointing to what we need to write predictable code. And yes, it does deal with these things, but I had two worries. One of them being, is it performant enough? Because there's going to be a ton of stuff. It's going to like, yeah, it's going to be a ton of reconciliation with this. Just imagine just a simple thing as changing the code of a module. So even now we have actually moved it to like a sandbox file system, but whenever we change the code of one of these modules, it means that whatever uses the sandbox file system is going to reconcile again, which is crazy. Like every time you hit a key, everything that uses the sandbox file system is going to reconcile again. And that just doesn't work. Just a file explorer that needs, like, that uses the sandbox file system to list the files, but that doesn't need to reconcile every time you change the code, right? And then you have this whole thing where you would need to normalize. You would kind of move the code into its own concept. So you couldn't have like modules kept in one object. We would have to like split this up into, we couldn't like have a reducer that has, where's the typing? Here we go. So we would have to have like code, and that would be module ID, like this, for example. So whenever we change the code, this is the thing we change, like this specific module ID. And then we would have to make sure that we pass only this specific thing down to like a React memo component, so it doesn't reconcile when the other modules are updating. Like it's so much work in React to make it performant. So much unnatural state, split it up to ensure like parents are not being changed by children state, which changes the parent state reference. And it depends, do you pass the child state directly with React Memo? If you use React Memo but you're passing like a parent state, it doesn't matter that you have React Memo because it will always change no matter. It's insanely tricky, and that's my biggest worry, is that I think this could work, but it would be so much work optimizing it. While with other concepts, we're just using MobX for the state management, and we just need to observe whatever we access, and then it just works. It's super optimized. Okay, cool. That's it for now. Thanks for joining me on this journey of reflection. Yeah, talk later.